Hey guys, welcome to question FM287 of the Further Maths Fortify study guide. This question reads, to prepare for a corporate function, 11 activities need to be completed. The network below shows these 11 activities and their completion time in hours. And then we're given this little network here, or this graph here, minus these divisions I've created for our earliest and latest starting times. Question A says, determine the earliest starting time of activity G. Looking at some of the other questions, it becomes apparent quite quickly that doing a forward and backwards scan of this network would be helpful to us in answering a lot of these questions. So we're just going to start off with doing a forward and backward scan of the whole thing. So we'll start with activities A and C, which are both going to have earliest starting times of 0. D will have an earliest starting time of 9. B will have an earliest starting time of 5. Looking at E and F, they're either going to have an earliest starting time of 5 plus 11, 16, or 9 plus 9, 18. We take the larger number there, so both of these starting times are going to be 18 and 18. From here, G is going to have an earliest starting time of 12 plus that 18 there. It's going to be 30, and H will have the same earliest starting time. I is going to have either an earliest starting time of 35 or 27. Once again, we take the larger number. J is going to have an earliest starting time of 30 plus 8, 38. And from here, K is either going to have an earliest starting time of 42, or it's going to have an earliest starting time of 48. We pick the larger of the two, 48. And then from here, we're going to finish it in 6 more days on top of that 48. So the finishing time should be 54. Now working backwards, 54 taking our 6 will give us another 48. 48 take our 4 here, lands us at 44. 35 take 13, sorry, 48 take 13, lands us at 35. 44 take away 8 should land us at 36. 35 take 5 lands us at 30. 35 take 9 should land us at 26. Now, E, we're going to either be working back from 30 or 36. As always, we take the lower of the two in this case. So we're going to take 30 when we're doing a backward scan. So we make this 18 here. And then D and B are either going to work backwards from our 18 or our 26. Once again, taking the lower of the two, the 18. Taking away 9 from 18, we get 9. And then taking 9 away from our 9, we get 0. Going along the other path there, if we take 11 away from our 18, we end up with a later starting time of 7. And if we take 5 away from our 7, we should end up with a 2. So looking at this network here, we can see that our critical path moves along these activities here. And this information helps us to prepare ourselves for the questions coming our way now. Cool. So question A asks, says determine the earliest starting time of activity G. So looking at G here, our earliest starting time is 30 hours. Now it's important to include hours there because we haven't had a unit defined for us, so we must let them know what the unit is. Question B, well, first of all, we're given a little bit more information, which says the minimum starting time in which all 11 activities can be completed is 54 hours. So we got a 54 here, which means that our 54 should line up with the one given in the book. B then goes on to ask, what is the latest starting time of activity J? So looking at activity J, we can see its latest starting time here is 44, once again including that unit hours. Question C asks us, what is the float time of activity F? So we've got a later starting time of 26 and an earlier starting time of 18. If we minus 18 from 26, we can see here that our float time is going to be 8 hours. We're given a little bit more information here. We're told that just before they start preparing for the function, the committee members realize the need to add another activity, Q, to the project. Activity Q will take 12 hours to complete. Activity H is the only predecessor to activity Q, and activity Q finishes with the project. What is the latest starting time of activity Q if it is not to increase the minimum completion time of the project? So from this information, you may be able to see that activity Q comes after H, so H is its only predecessor, and finishes with the project. Now, I don't normally use curved lines, but you can see here that this is where activity Q would travel along. So looking at this, or adding in activity Q's earliest starting time and latest starting time, we can see that it would also have an earliest starting time of 38. And given that it moves backwards from 54 without increasing it, taking off 12 from 54 should land us at 42. So it's got an earliest starting time of 38 hours and a latest starting time of 42 hours. And of course, question D asks us for the latest starting time, which looking at this, we can see is 42 hours. Awesome. So we're given a little bit more information before looking at question E. We're told that activity D can be crashed by up to 4 hours and at an additional cost of $110 per hour. This may reduce the minimum completion time for the project, including activity Q. So we're including this activity in our process here. E asks us, determine the least cost of crashing activity D to give the greatest reduction in the minimum completion time of the project. So this is where it's important for us to look at our float times. So you'll notice that we've got a float time of 4, another float time of 6, float time of 6, float time of 8, and then along here we've got a float time of 2. Now if we were to reduce activity D, everything that follows activity D is also going to be reduced. So everything from here on will also be reduced and will most likely retain its current float times. However, what won't keep its float times are activities A and B. As we reduce D, that will also reduce the amount of float time along this path up here. And an example, just to show you what would happen. Now, we're able to reduce D by 2 days before our critical path is taken over. And this happens because activity A and activity B take 5 days and 11 days, or 16 days all up. Which means that when I reduce D down to 7, and they also take 16 days, we now share a critical path along here. So we'd share a critical path along A, B, and then the rest of it, and C, D before the rest of it. If I was to reduce D by another day, A, B would take over as a critical path, and I wouldn't be reducing the overall completion time of the project. So our answer here is going to be 2 days at $110 per day. It's going to take $220 of extra cost in order to reduce the minimum completion time of the project by 2 days, which is the most we can reduce it by reducing D. So guys, that's all the questions within this question. If you have any final questions for us, please leave them in the comments below. Otherwise, I'll see you in the next video.